Visible now? Okay. All right. So we are going to start our today's session by just a quick recap on the few things that we mentioned yesterday. All right. And for part of the recap, I'll be doing it on the Python console. All right. All right. So we're just going to mention just on a high level about the things that we talked about yesterday. All right, and the first thing to we started by mentioning comparison and relational operators. So this is where we talked about operators like equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. All right. So for the comparison operator, the equal to, we basically mentioned like you just try to equate two numbers or to check if two numbers are equal. All right. And this does not necessarily mean that you must check two numbers. It can also be two strings. All right. So I can simply check if one is equals to one. And if this statement evaluates to, or rather this statement is true, then we get true as the output. All right. Basically, if one is equals to one, we expect to get a true as the output. All right. So if we try equating it to three, we get the output as false. All right. So that's the equal to comparison operator. All right, then we can also try to check if or rather we can also try to use the not equal to operator. All right, so let's try to check if one is not equals to one. So we said that this is how we denote the not equal to operator, and that is an exclamation and an equal sign. All right, so basically if whatever is on the left is not equals to whatever is on the right, then we expect to get an output of true. All right, so let's check. So in this case, we know that 1 is equals to 1. So it is false. It's a false statement to say that 1 is not equals to 1. That's why we get false. All right. So if we try to check on something like this, of course, we get true, since 1 is actually not equals to 3. So the other one was the greater than operator, whereby we are trying to check if the number on the left is greater than the one on the right. All right. So trying to check if 6 is greater than 3. So once this is evaluated, if it's true, we get true as the output. So basically we know by just looking at 6 and 2, we know that 6 is greater than 2. So we expect to get true as the output. All right, if we try to change that, we expect to get a false because 6 is not less than 2. All right, so in this case, this is the less than operator. All right, so this is the greater than operator and this is the less than operator. All right, then we also mention about a greater than or equal to, right, whereby we are kind of trying to have two cases whereby if or rather the statement will evaluate to true if the number on the right is equals to the number on the left, or the number on the left is greater than the number on the right. So let me use such an example. 5 is greater or equals to 5. All right. So in this case, 5 is not greater than 5, right? But we know that 5 is equals to 5. So this statement should evaluate to true. All right. So we can still do that and use 4. In this case, we know that 5 is greater than 4. So that statement we expect to get a true. But of course, we know that 5 is not equals to 4. So it will evaluate to true based on this greater than sign. All right. And of course, we have the less than or equal to sign. which now reverses that. So in this case, it should evaluate to true if number on this side is equals to what we have here, or whatever we have here is less than what we have here. So just by the look of things, this statement should evaluate to false. Right? So that is that for comparison and relational operators. That's a quick overview, and I believe it's now clear for each one of us on how to apply the different operator given the different scenarios that can be presented to you. Just do a recap of the things that we mentioned yesterday about the conditionals. All right. So we started by just talking about the if statement. All right, so in here, it's a pretty simple statement that will execute a block of code if the specified condition is true. All right. I'll still give an example that we used yesterday. Or rather, let me just create a new one. All right. So the pass mark. Let me talk about the pass mark. The pass mark is set to be, say, 60%. Right? Hope you remember the high school days where there were, say, mathematics contests, and they would be based on how you performed in your last term's exam. All right. So we want to select those who are to go for such a contest, and we have set the pass mark to be 60. All right. So we can use an if statement to tell if a candidate is qualified to go for such a contest or otherwise. All right. So we are going to say that so we can have student mark here, student score, all right, to be equals to, let me start with a 50 here. And of course, by the look of things, this doesn't qualify for that contest. All right. So we have if, so we are checking. All right. So in here, this is where you make use of the comparison operators. All right. Nobody is gonna advise you on which one to use. It's for you to try and look at the problem statement and know exactly the one to use. All right. So we are basically going to, or rather, from what I mentioned, is that we are going to select only those students who have scored 60 marks and above. All right. 60 marks and above. Let me use that 60 plus. All right. So we are going to check if student score, all right, it should be greater or equals to 60, or rather the pass mark. All right. So if the student score is greater or equals to the pass mark, all right, then we can just let the student know that you are selected. All right. So if this student scored some 60 marks, say 60% and above, then they are qualified to go for the contest. So let me try to execute this simple program here. Right. So I'll have Python. I have Python 3 and hello.py. All right. So by the look of things, this student scored a 50%, and the pass mark is 60. So we expect that they are not selected, but let's execute that. All right. So our program is silent on this student simply because they have not achieved the threshold. All right. So let's give them some 60 marks here. So the student scored 60. If we run the program, we see that this student has been selected. All right. Another thing, if the student say scored 70, all right, so we expect that this student also qualifies to attend such a contest. All right, so something that I want to mention here. Even before we get to writing the block here, they are the things that we mention here that will guide us on what we need to have here. For instance, we have said that for a student to qualify, they must have scored 60 marks and above. All right. Having mentioned that we must select a student who scored 60 points and above, then we have to use these two, the greater than and equal to sign. All right. So there is a scenario whereby we are taught that for a student to be qualified, they must have scored 60 marks and above. All right. So in that case, 60 is excluded. So whoever scored a 60 does not qualify. So in that case, we do not have to input, or rather we do not have to use an equal sign. So we basically want the student score to be greater than the pass mark. So remember the pass mark is 60. So if we have a 60 here, if the student scored a 60, we try to execute that, we see that our program is silent on the student. So a student who scores a 60 does not qualify. So every time you are using these operators, you must ensure to check or to read through the use case that has been presented to you, so that you don't end up including data that wasn't supposed to be there. All right. So again, we mentioned that it's not so good to be silent on the user. So this is where the else statement comes in. All right. So in such a scenario, we expect that either the student is qualified or not. All right. So in case the student is not qualified, let us just tell them that they are not selected. All right. That's where an else statement comes in. And again, also remember about indenting your code. All right. So once done with this statement, we said you terminate that with a colon. Press enter. It should be indented. All right. In case you happen to be using a code editor that doesn't do auto indenting, then be sure to push whatever we have here. Say using the tab once um, will be enough. All right. So again, if we want to introduce an else block, it has to be in line with if. All right. Then let's print here that we are just sorry. All right. Basically, if we tell them they are sorry, then I'm sure they will know that they should keep trying. All right. So if we rerun our program here, right? So that doesn't qualify. All right. Then I want to now bring in the elif statement. All right. So there are some rules in the contest that we want to take these students, whereby we can have pass mark 1. All right. Then we can have pass mark 2. All right. So this pass mark 2, these are probably some guys who will sit in for a different paper. So you kind of want to categorize the students, that is those students who pass, and there will be a category of students who will say do say paper 1 or attempt section A, and those who will attempt section B. So that's where we are bringing in a pass mark 2. All right. So in here we are going to check if a student scored, let me use scored rather, if the score of a student is above or it's greater than the pass mark. So in this case, let's make use of pass mark 1, right? So we can use you are selected for cohort 2, cohort 1. All right. Then in here, that's when we introduce an elif statement, checking if the student score is so in this case, let me see. So in this case, let's create our scenario like this, whereby if the student score is greater or equals to pass mark 1. So in this case, I actually wanted pass mark 1 to be that. and pass mark 2 to be that. All right. So in this case, if the student score is greater or equals to pass mark 1, then let's have them in cohort 1. All right. Then we make use of an elif statement. If the student scored, if the student score is greater or equals to pass mark 2, then we select them for cohort 2. All right. Then we run our program. So our guy or our student has 60%. So let's see if this works as expected. All right. So they have been selected for cohort 2. If they scored 50%. All right. We are sorry. Keep trying. If they scored 70%. All right. Still cohort 2. If they scored an 80%. All right. They are selected for cohort 1. So that's how to actually subject your program to different tests to see if it's good enough to give the expected output. Again, we wouldn't want our program to mislead its users. All right, so you have to subject it to different tests, and once you're happy with it, then in case it's to be deployed, then it can be deployed now to make use of the real data. All right. All right. Then there is also something that we mentioned. We mentioned something about there was something that we mentioned somewhere here. The use of and or. All right. So basically, this we can term them as logical operators. All right. And I'll do a quick demo. I'll do a quick demo from my Python console here. So in here, we kind of, in yesterday's illustration, we used kind of say real data, whereby we were trying to compare two blocks of data, whereby, for instance, when making use of and, if the first one returns true, and I mean the logical operator here is and the second one returns true, then that block evaluates to true. All right. So I'm hoping that was clear. Again, today I want to introduce a tree, something slightly different, but the same anyway. All right. So in here, when we are talking about the AND operator, all right. So we can have true and true, basically as they are here. Remember, yesterday we used a scenario that will evaluate to true, all right, and another one will evaluate to true to test whatever we have here. So we can simplify that and directly use true and true, all right, returns true. Again, we have true and false. Again, when talking about true and false, or true or false, this is how to write them. All right. If, for instance, you write false as using the lowercase f or small f, then it will throw an error. So it should be true starting with capital T and false starting with a capital F. All right. So true and false evaluates to false. All right. Let's see false, false, and false. This one again evaluates to false as we had seen here. All right. Let's see false and true again. All right. Again, it evaluates to false. All right. Then let's look at the OR operator, whereby we want to see true or false. Right. True or false gives us a true. All right. Then we have, all right. Okay. All right. So we have tested this one, true or false. Then we can test true or true. All right. True or true returns true. and false or false again returns false. All right, we can also have false or true, again should return true. All right, so we mentioned all this, but again, as I mentioned, we mentioned or rather we used illustrations of data. All right, just to demonstrate using and all, let's give an example here whereby we talked about we want to check on voting eligibility. All right, so we can have the age, whereby the age, we can set the voting age to be 18. All right, and we can also talk about uh, has has voter has voter card. All right, so we can set it to true. All right, so in here we want to check if this candidate is qualified to vote. All right, and for them to vote, they have to at least have, or rather they have to at least be 18 years of age and have a voter's card. All right, so this is how to subject the user who comes into the test. All right, so we are going to check if. All right, so in here we can talk about all right, so we can treat this as the user's age. All right, so let me use maybe 10. Let me use 10. So we treat this as the user's age. All right, and the voting age is at least 18 years old. Right, so we talk about if age is greater or equals to 18. All right, so that's one of the qualifications. Then we need to subject it to and. Then we can have has voter card. All right, so this one we do not need to check if it's true or not. I mean, by just having it having declared has voter card to true, and you just call it as it is, then it should return true. So you don't need again to subject it to equals to true. No. All right, so we want to check if the user's age is greater or equals to 18 and this user has a voter card. All right, then just let them know you can vote. All right, and maybe of course we can just have an else statement and print you cannot vote. All right, so let's check if our program gives the desired output. So in this case we are checking for a user who said they are 10 years old and they have a voter's card. All right, all right, you cannot vote simply because they are underage. All right, so let me give them 20 years. Let's see. So basically if we give them 20 years, at least we see these two evaluates to true. All right, so we expect to have we expect them to qualify to be voters. All right, so we see you can vote. Again, we can deny them the voters card and set it to false. Try to evaluate this. All right, you cannot vote simply because in here we are talking about this evaluates to true and this is false. All right, so we said true and false. Let's see, where did we talk about true and false evaluates to false. So again, if that's false, then it will not evaluate it here. It will work with this block. All right, so that's the use of and. All right, so again we can make use of or. Let me just change what we have here and change the rules of being a voter. All right, so for now I'm allowed to do that. So for you to qualify to vote, you either be at least 18 years of age or at least have your voter's ID. So even if you're 10 years old and you hold a voter's ID, then you are qualified to vote, right? So let's subject our our program to that check. So execute this. All right. So we see you can vote simply because they are at least 18 years of age. All right. So let's make them younger, 10 years, and this one is false. So basically, these two are false. So we expect that this is false. All right. All right. You cannot vote simply because these two statements are false. All right. So let's now proceed to something else. That was just yesterday's recap to ensure that we get things right. All right, so we now have groups. So when we talk about groups, we basically kind of get a chance to do some repetitive task on, say, some given data. All right, so I'll start with a simple one here because I think the best way to explain this is by use of an example. All right. So think of we have a list here of just some few entries here. All right. And you are required to add two to each of these entries. All right. So think of it. How do you achieve that? You are required to add two. I mean number two. So 1 plus 2, 2 plus 2 to each of these entries. All right, and maybe produce another list called Y, or even update the current existing list. All right, so think of how you can achieve that with maybe what you have already covered. Well, I'm not sure if there is a better way of doing that, but that will fall under for loops. All right, whereby we kind of go to each and every element in our list and do the operation at hand. All right. All right. So let's start with our first task here. We want to add two to each element in the list. All right. So this is how to approach this. For instance, by the way, even before we get to adding two, let us see how we can reference each and every entry. I mean, we would want to print each of these. Because if you remember, let me print X. Let's see how this comes out. All right. So if you print X, we get the full list. All right. But we want to deal with each and every element in this list. All right. So this is where the for loop comes in, and let me show you. So we are going to talk about for. It's a common practice to use for I. All right, just like even after saying that it's not a good practice to use variable names or rather a one-letter variable name, I still find myself using X and Y for some of these illustrations. So it's the same for loops. You mostly find yourself using I. All right, so it doesn't hold any special meaning here. We can use for X, for name, I mean, it's just like a kind of a variable name, a temporary variable name that we are making use of. So this is the one that will help us iterate on these elements. So we say for I in X. All right. So using some common English, we are saying that for each and every element in X, in the list X. All right. What do you want us to do? All right. We want to print I. All right. So this is how to do it. We want to print each and every element, like kind of individually. We are trying to kind of separate each and every element from the list, so that once we are able to do that, at least we are now confident that we can be able to do some operations on each and every element in this list. All right. So let's see the output of this. All right. So see what we get. So we have kind of now separated these elements from the list, and we can now list them one by one, as opposed to what we have here, whereby in here we listed that as a list. All right. So back to our problem statement here. We want to add 2 to each element in the list. We want to add 2 to each of these elements. All right. So I'll still add my 2 there. Let's see the output here. All right. So look at what you have. We have 1 plus 2, 3. 2 plus 2, we have 4. We have 3 plus 2, 5, and all that. All right. So again, we wanted to add 2 to each of these elements. All right. Then let's advance our for loop here. All right. So we will say add 2 to each element in the list, and and create a new list y from the output. All right. Forgive my English. What we want to do is, instead of just printing it on our console here, we would want this output to be saved in another list somewhere. All right. So what we need to do is we need to create another list y, and we can create that list outside our loop. All right. So we have created an empty list, and what we are going to do, instead of printing, we need now to have these entries into our new list here. All right, so I'm sure we remember something we mentioned about append. So we have y.append. All right, and what we want to append, we want to append I plus 2. All right, then once we are done with that, we can print y. All right, so let's execute this, and we'll elaborate what is happening. All right, so let me also print x here. All right, so this is what happens here. We have our list x. Then we have defined, like just reading through our problem statement here, we have mentioned that we are supposed to add 2 to each of these entries. Then after doing that, we need to create a new list and have the output of the output that we get here. We have it on another list named y, or any other name that you may find fit for your list. All right, so we require to create an empty list. Okay, so once we create an empty list, then we have for I in x, whereby we are now going attending to each and every element in this list. All right, so we start from index 0 here, 1, 2, up to the end. So we take 1, we add 2, then append it to y. We move to the second one, 2, we add 2, then append it to y, like that until we are, or rather we exhaust all the elements. So once we exhaust all the elements, then we exit from, or rather this program will automatically exit once it gets to the very last element here. Then we print x. That is what we print, then the new list that has been created here. All right, so a simple question will come: why do we need to print it outside the for loop? Because we, having printed it here, this is outside the for loop. Why not just print it here? All right, so let's see what will happen if we print it here. And I think once we see, you'll be able to tell why we are not supposed to print it here. Nothing wrong with it, but let's see. All right, so see what we form. So it will basically be printing this list each and every time we add a new entry. For instance, for I in x, so we started with 1, we added 2 and appended it to y. So at this stage, our y list will have one element, which is 3. All right, it goes to round 2, whereby it will add 2, then append it to our list. So once that is done, our new list will have 2 elements. That's what we have here. Then the next time it will have 3 elements, 4 elements until it gets to the very last element. All right. Then so this happens. The print y gets up to this point. Then these two are what we are seeing here. All right. Okay. Something else maybe that you'll find in loops is working with range numbers. All right, allow me to launch my Python console again. Okay, so this one, let me exit. I know there is a better way of clearing the screen, but let me use this one. All right, so imagine of a range of numbers. We want maybe a range of numbers from 0 to 10. All right, so there is this function here that you can give to give a range between 0 and 10. All right, so let me try to list and see what we get as the output. All right, so this is what we have. If you have a range of numbers, and in here we have given the start point and the end point. All right, so usually it will give you, if you talk about from 0 to n, so it will talk about n minus 1. All right, so in case you wanted to have a range of from 0 to 10 like 10 included, you need to mention about 10 plus 1, we have 11. So just introduced a range. So it's a common function that you find when dealing with for loops. So if you want another range of numbers, say you want from 10 to 20. So if you want 20 included, talk of 21. Let me print this. Or did I? Okay, all right. Actually, I wanted to convert it to a list. So that at least we can get those elements. I added something that is not necessary. All right. Okay. So we basically get a list from 10 all the way to 20. All right. So back to what we have here. Instead of maybe using x, we would want maybe to talk about for I. All right. Sorry. For I in say a range of okay. Let me slightly go back here. By default, a range will start from 0. So we can have that. All right. So you don't necessarily need to mention where the range starts. You can simply mention like where you want it to end. And remember, we said if you wanted to end at 10, it's 10 plus 1. All right. So you can make use of this as well. So you don't necessarily need to tell it to start from 0, but it's necessary when the start point is not 0. All right, so let's talk about range 10. All right, then so it's for I in range 10. So it will start from 0 all the way to 9. We can print I. Let's see what that gives us. All right, so we see that we have listed from 0 to 9. Again, in case you have any operations in mind, maybe you want to kind of multiply this by 10. All right, just do that and you get your output there. All right, let me try to simulate an example so that we can now incorporate whatever we have here. All right. Okay. Let me see if I can simulate a question very quickly to answer a question that had been asked. So I'm trying to think of, I have some students marks here. student marks. All right, and say the first student has 40, the other student has 55, the other one has 70, another one has 80, another one decided to score 19, we have another one having 79, and all that. All right, okay, all right. So we want to check if these students, or rather, we want to check on the students who qualify for a contest. All right. All right. So let us first of all try to see if we are able to rope through the student marks. As we said, we want to do for, we can talk about for mark in student marks. All right. We can print student mark. Okay. Sorry. We can print mark. All right. Let me talk about marks, not just one mark. All right. So I am basically trying to structure a question to check on the eligibility of these students to attend the mathematics contest. All right. So for those who are to go for the contest, let me see if they should have at least 50 marks. All right. So we want to, let me just kind of try to put some instruction here. Select the students with 50 marks and above. All right, so let's try to do this because we want to take these students somewhere. So um, students. All right, let me talk about student 50 and create an empty list in there. All right, so we have to check, or rather we have to do a for loop for marks in student. Then in here we need to check if marks, all right, if the marks that comes in is greater or equals to 50, then what do we need to do? Okay, all right, I need to use if. Sorry for that. So we are trying to check if these marks, the marks that we have listed here, is greater or equals to 50. Remember, our pass mark is 50. We want to take those students somewhere. So if marks is greater or equals to 50, then what do we need to do? We need to, okay, for now let's print that. All right, so what this simple program will do is that it will loop through these student marks. All right, and it will identify those students who scored 50 marks and above. Once it identifies that, it should print them on the console. Let's come here, rerun that, and we see that we have 55, 70, 80, and 79. So our 40% guy and 19% guys have been left out. All right, so we want to append these marks to this empty list here. So this is how to do it. Remember, talked about students 50 dot append, and we can append that marks. All right, so in here let's print students 50. All right, so in here we know that students 50 are those students who scored at least 50%. All right, so see, we have a new list with the students. So again, we may want maybe to have the other students less 50. Let me use that. Again, well, we take those who scored 50 and above to an outing, to the mathematics contest. We would want also to have a meeting with these guys so that at least we can have a word and see where the challenge is coming in. All right, so we would also want to have a list of those students. All right, so in our for loop here, we are still going to do the same thing, and when we are checking if we have student who scored 50 marks and above. Remember, if we start using an if statement, so when we make use of the if statement, if and else, we first of all have to sit back and look at the number of scenarios or the number of outputs that we can have. All right. So in this case, a student can either be 50 and above or less. All right. So in that case, in such a case where we expect those two scenarios to happen, then we can simply have if and else statement. All right. So we have if marks is above 50 or 50 and above, we append it to this list. Again, we have an else statement here, which we are now going to have students less 50 dot append, and we should append their marks in here. All right, let's again print that. All right, let me print that. All right, so this is what we have. So we have seen that those who scored 50 and above are listed there, and we have those who scored less than 50. So I hope we have seen you do not always need to work with a single student or a single entry. You can have a list of entry in the various data types that we have mentioned, and you're supposed to evaluate that to make a decision based on the output. So based on the output of these guys having scored 50 marks and above, we decided to append their marks to this list here. And the other decision that we made is that for those who scored less than 50, we append their marks in here. So we have a dictionary here that has some names with marks. All right. So in here, we also want to. Okay, you actually created the same with the same data. So let me copy and paste some stuff here and see how we can go about it. All right, so let's see how to go about working with a dictionary. That's another interesting data type that we can work with. All right, so if we remember, a dictionary has two elements in it. All right, it has keys. The keys are the names in here, and values. So let's see how to kind of print this data first before we think of the problem statement at hand. Right, so we are going to talk about can have name. So in this case, I'll talk about name and marks in our dictionary. So the dictionary is student marks, but we should talk about something. We should talk about items. All right, let me just take this dictionary first, show you something from my Python console in here. All right, so we can just talk about students dot items. All right, so it kind of destructures this dictionary to this form. So there's a form that we are going to read this data. All right, so when I talk about dot items, this is how it will be destructured. All right, let's see how that goes. All right, so in here we can talk about so we have said for name, grade in students, our student marks dot items, then we terminate that with a colon. So in here we can print, I'll use the f string, remember. So I'll print the name, and I'll also print the marks here. All right, not sure if it works. Let's see if we are able to get anything out of that. See how we are going to populate this. At least we can see the output. It's now the output of this dictionary in this form. All right, so let's see how to approach what we have here. So if we have that, so let me try to use an if statement here. If Okay, allow me to test stuffs here. So if max greater or equals to 50. All right, so what should I do with that? All right, let me try to do that. Let's break it into some points and see if things work. All right, interesting stuff, eh? Because we see that we only get a list of those who scored 50 and above. We don't have the 40 element and the 19 element. All right, so again, let me talk about the else here. Else. Okay, all right. So in this case, it might not make so much sense because all right, let me show you something. Allow me to introduce something that we haven't done in the past. So again, for this, I want to print those who scored less than 50 marks, right? All right. So we see we have these two. So we can advance what we have here and see if we can be able to append this data either to a dictionary. Let me see if we can create an empty dictionary as it is. Then come in here and talk about students 50. Then I talk about the name. All right. Then in here I need to talk about the marks. All right. So let's try these things out together and see if they work. Let me print student 50. Is it gonna work? Somebody? Let's see. Right, interesting stuff. Perfect. All right, so this is how to go about it. Let me also do this to this section here. So we get less than 50. Do the same. Name is equals to max. Then in here, can print. Let me print. What do I print? Student less than 50. All right, let's test our program. Okay, something somewhere went wrong. Something somewhere, indices must be, list indices must be. Okay, all right. So I need to create an empty dictionary by using those curly brackets. All right, so back to my program in here. So we see those who have 50, we see them here, and those who scored less than 50, we see them here. All right, so this is the approach. So we are presented with a dictionary. All right, so for now we should be in a position to pick a dictionary from a list of different data types. All right, and as we mentioned, a dictionary should contain keys and values. All right, then we are required to select students who scored 50 marks and above from this dictionary, and also select those who scored less than 50 marks. All right, so once we do the selection, we are supposed to group these categories of students into two. All right, and so to approach this question, we create two empty dictionaries here. All right, then to loop through a dictionary, this is the approach. And if we have had a conversation about when learning these programming languages about you creating a template, this is the template. All right, so this is the start point of you printing the entries of a dictionary, whereby you can talk about the name and marks, or I and J. You don't necessarily have to have name and marks here. It's only that we used these two because to us they make sense. These being the keys, being the names, and marks being the values. All right. Then we talk about students.items. All right. If as you have seen, we tried to print the different elements after doing the for loop and all that. So again, we are still not yet, we have still not yet answered this question. We just did a for loop, and at least we are now able to loop through the items that we have here. All right. So from um, from this loop, we try to check if the max that comes in is greater than 50. So if the max for, say, for I, because think of this as for I, because the first entry we do like for I, and we get the name and max. So out of the max that we get in the first loop, we check if the max is above 50, is 50 and above. All right. If it's 50 and above, then we kind of update our empty list. If you remember when we were talking about dictionaries, sorry, not the empty list, but the empty dictionary. If you remember when we were talking about dictionaries, all right, let me create a dictionary here very quickly, just to remind you something. Remember, we said that you can add some elements to this dictionary by doing this X. Then in case you want the key to be name, all right, you can do it like that. Then the value to be, sorry, say you want the name to be done. All right. So if I print X, we see that. And again, we also talked about you can also do X dot update. All right. We are not going into that, but I hope you remember this. So if you remember this, then this is exactly what we are doing here, whereby we want to update our dictionary, and the first thing to set is the key. All right. So in this case, the key is the name, because we are looping through name and max. So in this case, we are not going to have the name in quotes. All right. Then we equate that to the value, and the value in this case is the max. All right. So once we are done with that check, everything else goes to those less than 50. All right. So as I mentioned, the goal is to find as many problems as possible, or you can either get problems online or try to create problems and use code to solve those problems. So this one might look a bit easy because it's data that you can be able to sort out. Say this got a 40, get into less than 50, 50, get in here, but then you might have data that has, say, 1,000 entries. All right. So instead of spending an hour trying to sort things out, just write some 5-6 lines of code to get your task done. All right, so let's now move on. Let's now make some progress. So in here, if we remember, we had for loop and while. All right, so while loop is another kind of loop. I'm not sure if it's so common, but let's see how while loop works. So basically, a while loop, what a while loop does is that it will continue doing something or executing a code, a block of code, as long as a given statement remains true. All right. So we might need a little bit to be careful when executing while loops, because it can make your machine freeze. It's not a harmful thing. It's only that it can run into an endless loop. I mean, something that doesn't, for instance, if you are to tell it to, let me give you a scenario, like you tell, let's even forget about Python and the loops that we are talking about. All right. So we know that 0 is less than 1. All right. Let's prove that. Okay. Let's prove, that 0 is less than 1. All right. So if you are told, like, start doing something and please stop when this statement becomes false. All right. while doing nothing to this statement. Like no operations are being done on this statement. And you have been told start doing something until this statement becomes false. So that means you will continue doing whatever you have been requested to do till eternity, because at no one time will this change to false. So that's the same way with while loops. So when you're kind of planning to have a while loop, you should ensure that you foresee that it should come to an end at some point, right? So let's see how to kind of go about it. Anyway, should it make your machine freeze, just press on the power button. It will switch off and then start it up again. All right. So let's do this. All right. So this is how to do it. So we are going to talk about while. We can talk about I. All right. While I is less than 5. What do you want us to do? You want me to print? I can't be printing hello world. All right. So as long as I is less than 5. So as you see, we need to define I somewhere. I is equals to, let me talk about 0. So look, when I is less than 5. So currently, if we look at I, this is 0. And I just want to make use of this console because look at the first, immediately we execute this loop. The first I is equals to 0. So we know that I is I is less than 5. All right, we are in agreement. So this block will be executed simply because I is less than 5. So if you are to execute this, then you are kind of telling this loop to run till eternity. So to prevent that, you need to do something to this I so that at some point it comes to an end. All right. So the way to do that, you can talk about I. We can talk about I equals I plus 1. Like you take I, add 1. All right. So in this case, we are a bit safe. But as I mentioned, should I go silence? Please wait for me. Give me like 5 minutes to boot up and set up everything. All right. So let me do that. Let's go. All right. So see, we have gotten 5 hello world. All right. Simply because it is started from. I mean, for the i's that will make this statement true, we have 0, 1, 2, 3, 4. So is 5 this 5 is 5 less than 5? No. So it will execute until I is equals to 4. All right, that's why we have 5 outputs. All right, so think of it being, say, 100. Let's see how fast this code will execute. All right, put it to 1,000. Very fast. 10,000. All right, so there are so many here. In case you can look at this scroll bar here, there are so many entries. All right, so if you don't take care, it might now make your machine freeze. So as this number becomes bigger and bigger, then that's how it will continue consuming the power of your PC. All right, so something I want to show you here. I want to show you something here. So we have x is equals to 5. All right, so we can have x. I want to add 1 to x. Once I add 1 to x, I want to assign it back to x. So I can have something like x is equals to x plus 1. All right, if I print x, I have 6. I can go back there, do that again, print x. I get 7. So there is a shorthand to doing this. Instead of like, having x is equals to x plus 1, I can simply have x plus equals 1. So basically, what we have here is the same as doing this. All right, so if I do that and have x, I have 8. I do that, I have x, I have 9. So I just wanted to kind of show you how to simplify this. In some cases, you will find people using, instead of I is equals to I plus 1, just use I plus equals 1. All right, the rest of the thing should work. All right, and again, you don't just have to add 1, you can decide to add 2. All right, if you do that, then that's the output. In here, you must not always use 1, you can add 2, but the goal is to ensure that this will make your loop come to an end at some point. All right, and again, if the loop runs for so long, say you talk about, say, a million here or a billion, that might also make your machine freeze, simply because it might consume a lot of resources trying to process that until it's no longer able to process anything else. All right, so again, I mentioned that I haven't seen it so popular. It's not so popular, but in case you come across it, please note this is how to use it. So the key thing, just pay attention to whatever operator that you use here and the change that is happening here, so that at some point your while loop comes to an end. All right,